Hi friends, my today's video is on the topic arithmetic progression. But before we understand the meaning of arithmetic progression, it is important to understand what is meant by a sequence and a series. Then later we will discuss about how to find a general term of arithmetic progression. And in part 2 of the same video, we will discuss about sum of n terms of the arithmetic progression, the derivation as well as the formula. Let's start with the sequence. Let's try to understand the meaning of sequence.
Here are the few examples of sequence. 1, 3, 5, 7. Second one is 1, 4, 9, 16. Third, 1, 1, 2, 3, 5, 8, 13. Next one is 3, 9, 27, 81. If we observe, all these numbers are written in a specific order. In first case, if we add 1 to each term, we will get the next term. For example, 1 plus 2 is 3 and 3 plus 2 is 5, 5 plus 2 is 7 and so on. Second sequence is actually squares of natural numbers. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and so on. And the fourth one is Fibonacci sequence, in which the first two terms are 1 and next term is obtained by adding the previous two terms. For example, 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, and next term will be 13 plus 8, which will be 21. Fourth sequence is actually the powers of 3. 3 raised to power 1 is 3, 3 raised to power 2 is 9, 3 cubed is 27, 3 raised to power 4 is 81, and so on. And the last is minus 85, minus 79, minus 73. If you observe, we have added 6 in each term to get the next consecutive term. So adding 6 in one term, we'll get the next one. Minus 85 plus 6 is minus 79, minus 79 plus 6 is minus 73, plus 6 is minus 67.
So friends, set of given numbers which follow a set of rules is defined as a sequence. Sequence and series, these two words seem to be similar, but the meaning is different. Let's try to understand what is meant by a term series.
Series is actually sum of certain terms of a given sequence. For example, 1, 3, 5, 7 and so on was a sequence, and the sum of these terms will form a series. Similarly, 1 plus 4 plus 9 plus 16, if we add certain terms of a sequence, we obtain a series. So series is nothing but sum of certain terms of a given sequence. Let's go back to our previous sequence and see the difference between the consecutive terms. In first sequence, the difference between the consecutive terms is 2, 2, 2. Next one is 3, 5, 7 and so on. And here are the differences of the rest of the sequence which we just discussed. And important observation is, in the first and the last sequence, the difference between the consecutive terms is same. So friends, whenever the difference between the consecutive terms of a sequence is same, that sequence is defined as an arithmetic progression. So the first one and the last one are the arithmetic progressions because the difference between the consecutive terms was same.
So my friends, I hope the meaning of arithmetic progression is very clear. As far as definition is concerned, arithmetic progression is defined as a sequence in which the common difference of consecutive terms is same. So this is how we can form an arithmetic progression if its first term and the common difference is given.
Let's take an example. We have an arithmetic progression with 1, 3, 5, 7. Here the first term is 1 and the common difference is 3 minus 1, which is 2, which is also equal to 5 minus 3 and 7 minus 5. So here is the first term 1 and the common difference 2. This arithmetic progression can be rewritten as, in this arithmetic progression, suppose only first term and the common difference is given, we can obtain an arithmetic progression by adding 2 in each term in order to obtain the next term. Let's see how. The first term is 1. If I add 2 to this term, I will get 3, which is the second term. If I add 2 to the next term, that is 3, I will get third term, which is 5. If I add 2 to 5, I will get the fourth term, that is 7, and so on. I'm going to further decompose the terms. 3 will be written as 1 plus 2, 5 will be written as 1 plus 2 plus 2. Now the same arithmetic progression I'm going to rewrite. I will write 2 plus 2 as 2 into 2, 2 plus 2 plus 2 as 2 into 3, and so on, and this is what I get. So the arithmetic progression ultimately can be obtained as first term plus d times n minus 1. It means if I want to obtain fourth term will be equal to first term, that is 1 plus 2 times, 2 is a common difference, 2 times 3. Similarly, if I want to obtain 50th term, I will write it as 1 plus 2 times 49, because 49 is 1 less than 50.
Let's try to generalize the formula to find nth term of an arithmetic progression without finding the previous term. It means if I want to find the 100th term of an arithmetic progression, is there any way so that I can find the 100th term directly without actually finding the first 99 terms? Let us try to find it out.
How to form an arithmetic progression? Let's generalize it. The first term is a, second term is a plus d, third term is a plus 2d. Similarly, my friends, if I want to find the 50th term, I will write it as a plus 49d. 100th term similarly will be a plus 99d. 500th term will be a plus 499 times d. And the nth term will become a plus n minus 1 times d. So friends, this is the general formula to find nth term of any arithmetic progression. An is equals to a plus n minus 1 times d. Suppose nth term of any sequence is given to us and we want to check whether that an is nth term of an arithmetic progression or not. How will we do that? Let's take few examples and discuss. So here are the few examples. In first case, an equal to 4 plus 32 times n. Second, an equals to 5 plus n square, and there are the rest of the examples. What will we do? We'll find the first term, second term and third term, and we will check whether the common difference is same or not. I will put n equals to 1, I will get a1. So in first case, if I put n equals to 1, I will get 32 plus 4, which is 36. If I put n equals to 2 in first case, I get 32 times 2, which is 64, plus 4, which is 68. And similarly, n equals to 3 will give me the third term. And the same thing I am going to do in rest of the examples also. I will put n equals to 1 to obtain the first term, put n equals to 2 to obtain the second term, and put n equals to 3 to obtain the third term. And the same if we'll do in all the cases, this is what we'll get. And let us observe, in first case, the difference between second and first term is 32, and the difference between third and second term is 32, means common difference is same in first case, whereas in second case, the difference between first two terms, that is 9 and 6 is 3, 14 and 9 is 5, common difference is not same. Second one is not an arithmetic progression. Third one, the common difference is 6 in all the consecutive terms, hence the third sequence also is an arithmetic progression. The fourth one, if we observe, yes, again the common difference is minus 12. So fourth sequence is also an arithmetic progression, whereas fifth is not. The difference between first two terms is 6, whereas the last two terms is 38, which is not an arithmetic progression. So the blue colored ones are the arithmetic progressions, the first one, third one, and the fourth one. One important observation in these 5 nth terms is, whenever the nth term is linear, that nth term represents the nth term of an arithmetic progression, because the general formula to find nth term is a plus n minus 1 into d. And if I open the brackets on the right hand side, this is what I will obtain. A minus d plus n times d, which is a linear in terms of n. Hence, If nth term of a sequence is linear, then it will always form an arithmetic progression. And another important thing, you put n equals to 1, you will get the first term. And the coefficient of n will give us the common difference. I repeat, put n equals to 1 and get the first term. Coefficient of n is the common difference. So friends, let us take examples. In all these examples, I will put n equals to 1 to get the first term, and the coefficient of n will be my common difference. And if I know the first term and the common difference, I can form any arithmetic progression.
So friends, if the general term of a sequence is given to you, that is nth term of a sequence is given to you, it will form an arithmetic progression if and only if it is a linear expression. Otherwise, it won't form an arithmetic progression. In order to find the first term, we will substitute n equals to 1, and the common difference in that linear expression will be equal to the coefficient of n. Let's see in the given examples.
Form an arithmetic progression in the following examples. An equal to 6 and minus 4. Yes, it will form an arithmetic progression because the right hand side is linear. If I substitute n equals to 1, I will get the first term, that is 2, and the coefficient of n is 6. So my common difference is 6. If I put n equals to 1, I will get the first term, which is 2, and the coefficient of n is 6, which is my common difference. So 2 is the first term, 6 is the common difference. My arithmetic progression will be 2, 8, 14, and so on. In second case, an equals to minus 2n plus 8. Again, put n equals to 1 in order to obtain the first term. If n equals to 1, I will get the first term, that is 6. And the coefficient of n is minus 2. My common difference is minus 2. First term is 6. Common difference is minus 2. My arithmetic progression will become 6, 4, 2, and so on. In third case, an equals to minus 5 and minus 7. If I substitute n equals to 1, I will get minus 12. So friends, my first term is minus 12. And coefficient of n is minus 5, hence the common difference is minus 5, and our arithmetic progression will become minus 12, minus 17, minus 22, and so on. Example. In 43, 49, 55, find 56th term. First of all, let's check whether it is an AP or not. What is 49 minus 43? It is 6. 55 minus 49 is 6. Yes, it is an arithmetic progression. So I'll able to apply the formula to find nth term of arithmetic progression. So first of all, I'll write that first term A is equal to 43 and common difference is equal to 6. Now 56th term, we know that 56th term is equal to a plus 55 times d, which is nothing but 43 plus 55 times 6, and the answer is 373.
So friends, this was all about the sequence, series, definition of arithmetic progression, how to find nth term of an arithmetic progression, and how to identify whether the given sequence whose nth term is given forms an AP or not. In second part of this video, we will discuss about how to find sum of n terms of an arithmetic progression.